Hello students, welcome to the 8th video in the series Microwave Layout Analysis. Here is the microwave layout for 1-bit SRAM using transmission gate switch. As compared to the previous layout, everything is same and except that the NMOS switches N1 and N2 are replaced by transmission gate switches. So here we have the first CMOS inverter I1. Here we have the second CMOS inverter I2, and the output of I1 is connected as an input to inverter I2, and the output of I2 is connected as an input to inverter I1. That is, they are connected in a cross coupled fashion. This is my transmission gate 1 and this is my transmission gate 2. Enable equal to 1. This is the control line C of the transmission gate, which is equal to 1. Similarly, this is the control line of the second transmission gate, C equal to 1. As we know that when the gate of NMOS of TG receives a 1, then transmission gate closes or it turns on. So we can see here that for C equal to 1, the first transmission gate TG1 is on. Similarly, the second transmission gate TG2 is also on. Now, right line is equal to 0. As we know that a transmission gate transmits a 0 as a strong 0 and 1 as a strong 1. So the input node of transmission gate 1 is the right line and the output node of transmission gate 2 is the read line. So 0 at the input node of TG1 renders a strong 0 here. Strong 0 given to I1 is converted into a strong 1. Strong 1 is given as an input to I2 and I2 converts strong 1 into strong 0 and the system stabilizes. This strong 1 now goes over this line here, that is the input node of transmission gate 2. So with a strong 1 at the input of transmission gate, the read line is equal to strong 1. So we see here, unlike 1-bit SRAM cell using NMOS switch, wherein for right equal to 0 we got a weak 1, here we are getting a strong 1 which is acceptable. Okay, let us analyze for right equal to 1. Here again with enable equal to 1, that is the control signals of both transmission gates at 1, TG1 is on and TG2 is on. If right line equal to logic 1, TG1 being on, it transmits 1 as strong 1. Strong 1 is applied to input of I1. I1 converts strong 1 into a strong 0. Strong 0 is transmitted to the input of I2 and I2 converts strong 0 into strong 1 and the system stabilizes. Over this line, strong 0 is transmitted on this line here and strong 0 applied at the input node of transmission gate, it transmits it as strong 0. So again, for write equal to 1, we get read equal to strong 0, which is again acceptable. Let us analyze for enable equal to 0. For enable equal to 0, we have the control signal of Tg1 as 0 and control signal of Tg2 as 0. As we know, in a transmission gate, if the gate of NMOS receives a 0, then here it is 0. This inverter converts C equal to 0 into a strong 1. Strong 1 goes here and this NMOS becomes off. For C equal to 0, this NMOS is also off. Here again, for C equal to 0, this NMOS is off. C equal to 0, translates here as strong 1, strong 1. Again, this NMOS is off. In other words, for enable equal to 0, Tg1 is off and Tg2 is off, and there is no connectivity between the write line and the read line because Tg1 and Tg2 are turned off or they are open circuited. So even if I1 and I2 are always on systems, because the write line is disconnected from the cross coupled inverters, that is why for any value of write, the output does not change. Let us see what the simulation shows. For enable equal to 1, write equal to 0, you can see here for enable equal to 1 and write equal to 0, we get read equal to strong 1 because it is attaining a value 1.2 volts, which is nothing but the VDD for 90 nanometer technology. For write equal to 1, enable equal to 1, write equal to 1, we get read equal to 0.0 volts minus VSS, that is a strong 0. For enable equal to 0, enable equal to 0, write equal to 1, we are obtaining a read equal to strong 0. Let us change the write to 0. Enable equal to 0, write equal to 0, read is again equal to strong 0, which means that irrespective of the change in value on write line, the read line does not change it, that is, it is don't care. So we can conclude here that for enable equal to 1, write equal to 0 leads to read equal to strong 1 and write equal to 1 leads to read equal to strong 0. Both of them are acceptable. For enable equal to 0, or write equal to 0 or 1, read thank you very much.